Welcome to the new series on LambdaTest, where we'll be talking about Selenium with C# on NUnit Testing Framework. In this series, we'll be covering a lot of topics related to what NUnit is and its advantages, setting up NUnit within local machines, and running first NUnit test, how we can run an NUnit test along with Selenium on LambdaTest platform, and how we can leverage the power of NUnit parallel execution with LambdaTest platforms. And finally, we're going to perform tunneling to run test on application hosted in the local machine from via LambdaTest platform. So these are the topics that we'll be covering in this series, and we'll see how we can leverage the power of NUnit for our test automation with LambdaTest platform. And in this video, we can talk about NUnit introduction. So what is NUnit testing framework? Well, NUnit is a unit testing framework for all .NET languages. It has support of .NET 5 and the .NET Core framework. NUnit is also extended by other tools to perform tool-specific actions like SpecFlow, for example. If you have used SpecFlow before, you would have seen SpecFlow NUnit is one of the dependency that you will be adding in your SpecFlow project because it extends its own SpecFlow specific NUnit hooks to run the test. And there are many advantages of having NUnit within your test because NUnit test framework helps to run the test in parallel, sequence, and the order that you specify. So these are the things which are going to be very helpful while we try to run any test that we have written. NUnit test can be executed via command line with different parameters which can be used to run the test. And that's exactly what we'll be doing in this series as well, while we try to pass different parameters or environment variable from LambdaTest platform to the test that we have written and change or modify the behavior of how the test actually executes. And NUnit actually has many inbuilt attributes as well, and using these attributes we can decorate a C# method as a test method or as a test fixture or a hook, something like that. And NUnit's assertion will help to perform pass-fail of a test that we are executing. And this is exactly what is required while we try to run our test on any testing platform and also within our LambdaTest platform. And finally, NUnit has got a lot of support with the IDE that we work. For example, in this series, we'll be using Visual Studio, and we'll see how NUnit test adapter features allow NUnit to run inside Visual Studio 2019. Well, as that said, the NUnit sample test structure is going to look something like this. It is going to have a class which will be decorated as a test fixture, and it's going to have a setup method. And as you can see within the setup method, we mostly use to set up, for example, Selenium WebDriver to invoke a browser, or it can be a database which will be set up to perform a connectivity or opening a file, something like that. And similarly, there will be a tear down method which is going to perform a cleanup operation. And this is going to be like cleaning up our Selenium WebDriver or closing the WebDriver or disconnecting the database or closing a files and things of that nature. And the actual test itself. As you can see, here is where we are going to perform our actual test. For example, Selenium test to perform a login operation or user detail filling operation or settings operations and things of that nature. And here is where we'll be doing our assertion operations. And all these methods are actually decorated by attributes like setup attributes, test attributes, and tear down attributes. And this is the very super simple basic NUnit sample test structure. But if we're gonna have a different fixture level or parameter level within our NUnit test, then the code is gonna look something like this. As you can see, within this test, we have something called as a test fixture with different parameters in it, like Chrome, version of the Chrome, and the operating system like Windows 10, something like that. And because we are passing different parameters, these parameters are consumed within the properties of a class file, something like these. And these properties are then going to be assigning the value based on the order that we have specified within the test fixture, within the properties within the class file. And then these values are going to be used within either the setup method or test method or even in the tear down method. So this is how we actually use the parameters within the test, and these parameters can also be passed from NUnit console if we would like to run the test from the CLI. And once we execute this test, the output is going to look something like this. As you can see within the test, we actually have the parameter being printed like Chrome, the version 87.0, and Windows 10 as the operating system. So this is how we can actually run a test using test fixtures and different hooks or attributes of NUnit and make use of NUnit Framework in different types of tests within our organization. Welcome to the next lecture of our Selenium with C# NUnit series, and in this lecture we'll be talking about NUnit setup and prerequisite. Well, in this whole series, our ultimate goal will be to run an UI-based application test in LambdaTest platform via NUnit Framework. Assuming the application is already available via public network, we are going to be using that application to run the test within LambdaTest platform. So the scenario is going to look pretty much like this. We are going to have our test written in NUnit, Selenium, and C# with Visual Studio, and then we'll be running this test and we'll be consuming an application which is available on the public domain, and we will be running this setup of test on LambdaTest platform. So this is how mostly the setup going to look like while you're going to be using the LambdaTest platform, and for this the prerequisite is going to look something like this. We need to have .NET 4 or above or .NET Core 2.0 or above installed within our machine, and this framework installation automatically comes if you install Visual Studio 2017 or above. And we also need to create a project which should have dependencies for Selenium and NUnit test frameworks. So these are the setup dependencies and prerequisite that we need to have within our test while working with NUnit testing framework and Selenium in C#. Let's quickly try to create a C# NUnit project in Visual Studio 2019 and see how we can install all the dependencies. In this video, we are assuming you have Visual Studio 2019 installed within your machine. Alright, I'm going to create our first NUnit test project within my machine right now. So this is Visual Studio 2019, which is already installed within my machine, and I'm going to create a new project. So I'm going to hit this create new project, and it's going to bring all the project templates. And the project templates which we are interested in is going to be the NUnit project template. And this brings the list of framework which is available within our machine. And I'm going to choose the NUnit test project with .NET Core because .NET Core is cross-platform and it is much sophisticated to run on multiple different platforms. And I'm going to hit next, and I'm going to create a new project. I'm going to name this as LambdaTest NUnit demo, and I'm going to hit create, and this creates a project for us. As you can see, once we choose the project template, Visual Studio 2019 automatically creates the NUnit test class template, which has a setup attribute and test attribute in it. It also adds a dependency for NUnit framework, while you can see the same dependency available within the packages over here. And you can also see that there is a NUnit 3 test adapter, which actually is helpful while we can run the test using Test Explorer. And you can open the Test Explorer using this test option and just choose this Test Explorer. And this Test Explorer can be attached over here. And you can see with Visual Studio 2019's auto discovery option, it will automatically discover the test that we have created over here, which is nothing but the test one, this one. So automatically all the dependencies are added for us. The final dependency that we need to add is Selenium dependency, but we can add that while we talk about running this Selenium test using NUnit in our next video. Welcome to the next lecture of our Selenium with C# NUnit series. In this video, we are going to talk about running Selenium test using NUnit test framework in both local machine and in LambdaTest platform. In our last video, we talked how we can set up the NUnit and how we can install all the prerequisite software within our Windows 10 machine and create a sample test, something like this. And in this video, we are going to write a simple Selenium test and run on the Selenium Grid server in local machine and run the same test on the LambdaTest platform. So the first thing which I'm going to do is I'm going to install the Selenium dependency within my project. So I'm going to search for Selenium and I'm going to install the Selenium webdriver. And while this is happening, I'm also going to invoke the Selenium server for role, node, and hub so that I can run the test on the Selenium server. So I have started the Selenium hub using the command java-jar, the jar file name -role as hub. So this is going to be the hub, which is going to accept the incoming request. And this is the node java-jar of the Selenium jar file -role as node, which is going to execute operation which is being specified within our client code over here. So now everything is set up for us. The Selenium dependency is being added within our project, and the Selenium Grid server is also up and running. So all we're going to do is to point to our this URL to run our test that we're going to be writing. So I'm going to write a very simple test which is already available within our LambdaTest platform as a sample test over here, and run the same within my local machine and then on the LambdaTest platform. So I'm just going to copy the code from here. So you can get all the code for different language binding like Java, JavaScript, C#, Python, PHP, Ruby. For all these language binding, you can get the sample codes, and I'm going to be copying the code which is already there on the LambdaTest platform. So I'm just going to copy them and I'm going to paste it on the test over here. But as you can see, for running the Selenium test, we require the Selenium driver, and we also require the browser which we are going to be executing the test. For this test to run within my local machine, I'm going to actually run just on the Chrome browser. So I need the Chrome options to be specified for the iWebdriver. So I'm going to create a private variable for iWebdriver, and I'm going to add the reference by hitting control dot, and I'm going to add the reference using openqa.selenium, and I'm going to set up the Chrome options as new Chrome options. Because we're going to be running the test on the Selenium Grid, we need to invoke the remote web driver. So I'm going to call the _driver is equal to new remote web driver. I'm going to add the reference, and I'm going to specify the new URI localhost that we are running within our machine. And we need to add the reference for the URI. And then we need to pass the capability, which is nothing but the Chrome options dot to capability. So this way we are ready to go with running our actual test on the Chrome driver. But since we have specified the _driver and the copy pasted code is actually of driver, I'm going to replace this code to just driver. So this way it's going to run the test for us. And I think the send keys is going to be first item, and I don't really want to do any assertion at the moment. I'm just going to remove them. So this is the test that is going to be running within our local machine right now. And since we have a setup, we also need to perform a teardown, which is going to close the driver for us. So I'm just going to do that as well, which is going to be looking something like this. So now that our code is fully ready, but before running the test, we also need to first navigate to the URL which we are actually interested in, which is nothing but the LambdaTest's sample to do app. So I'm just going to do that as well. And everything is right now ready for us to run the test. So I'm just going to right click the test, and I'm going to hit run test so that it is going to run the test for us. And you can see that the capability is being received, and the browser is launched, and the Selenium test has been executed, which is quite good. So our test is actually running fine within our local machine. The next step is to run the same test on the LambdaTest platform. So in order to run the test on the LambdaTest platform, all you need to do is to sign up for a free account within your LambdaTest platform and start running the test straight away. And you also get a concurrent session of 2, which means you can run the same test parallelly for 2 browsers in 2 different environments. So I have already logged within my LambdaTest platform, and I already have access to all the greatest features which the LambdaTest offered to me. At the moment, you can see within the automation tab, there is no test available, and I have not executed any test at the moment. And I'm going to run my first test within the LambdaTest platform. In order to do that, I need to connect my local test to the LambdaTest platform using access keys, which I can obtain from my profile in the settings, and I can grab the access token which is available for me over here. Not only that, we can also get a detailed information of how to connect the local machine code with the LambdaTest platform if you go to the automation tab, and if you click the get started option, you will get all the information of how you can actually connect. So in order for you to connect your test from your local machine to the LambdaTest platform, you actually require the username, the access key, additional desired capabilities. Within this capability, you can actually see that there is a lot of information already available. Something like the platform which you're going to be running the test for, the browser name, the version, and the resolution, and the build name, and the network. Do you want to capture the visual information, the video information, or the console log? So you can specify all these additional capabilities within your Chrome option, and then you can run the test. So these are the things that you can actually get as a template within the LambdaTest, and then you can run the test for. And since we may also require to run the same test on different browsers, not just on the Chrome browser, but also in the Firefox browser or Safari browser, and in different platforms like macOS Big Sur, the capability changes, and you can actually grab those capability values from here. So you can choose the capability something like macOS Big Sur, and if you choose the browser as Safari, then you can see that the value will be reflected for you automatically. And if you think you actually need to get this information without logging into the LambdaTest platform, then you can search for LambdaTest capability generator. And if you select this URL, you can see that the same options that you get from this page will be obtained from here as well. So you can choose the version of Selenium that you're using, and you can see that it will show you the Chrome options and its capability that you need to be adding for. So this time we actually require not just the remote capability option, but also the additional capabilities option. And because we were running the test on our local machine before, we actually used the URL something like this. And because this time we'll be running the test on the LambdaTest platform, the URL will be a bit different. And if you go over here, you can see that the URL will be something like this: the username access key at hub.lambdatest.com/wd/hub. So this is the URL of the hub that we will be running the test for. So we can actually grab the code even from here so that we can save our time. So I'm just going to copy that, and I'm going to be pasting that over here, and I'm actually going to replace them a bit, something like this. And the username and password is going to be something that I will be specifying in from within my test. So let me just comment this code for now, and let's try to do it from the beginning. The first thing which I require to run my test is actually the capabilities, and also the username and the access key properties. So in order to do that, I'm actually going to be creating a series of properties which I require to run the test for. So these are the properties which I require right now: the browser, the version, the operating system, the name of the build, the username, and the access key to connect to the LambdaTest platform. And I need to initialize these value from within my test using a constructor something like this. So this is the constructor which is going to initialize the whole value that I'm going to be passing in. And then I'm going to create the capabilities which is required for running the test on the LambdaTest platform. So I'm just going to use this, the Chrome option, add additional capability, and over here I'm going to specify something like the platform, which is going to be the operating system which I'm actually getting in, and I need to set the isGlobal capability as true because this is a global property that we are going to be assigning within our capability. And similarly, I need to assign the Chrome option with additional capabilities, something like the version, name, and the build and the access tokens, which is going to be looking something like this. So the version, the name, the build, the username, and the access key that we have specified. So we have set all the values over here. Now we are pretty good to go with setting this particular Chrome options as a capability within our LambdaTest URL that we have. So the URL now I have uncommented, and I'm actually going to set this particular value using the username that we have got, which is nothing but the LT username colon LT app key. And let me remove the additional plus sign. And then the capabilities is going to be the Chrome options dot to capabilities. And with this, we can see that we are now all set to run the test on the LambdaTest platform. I'm going to comment the local test which we were running before so that we can use this anytime if we wanted to. And now this is the LambdaTest connectivity. And now you can ask me, where is this information of the platform versions, name, and the operating system is going to be coming from? Well, we can obtain these information using what is called as the test fixture of the NUnit. So I'm going to be using that particular option to initialize the value for me. I mean, this is the same concept which can be used even for our parallel test execution, but I'm just introducing this already so that we can understand that much better in our next video. So now that our test is already available with browser, its version, the operating system, and the name of the test that we're actually executing. So you can see that all these informations is already available, and now we can try running this test and see how it actually works. So to recollect, we have already set the test fixture to run on different environments, and we have created the connectivity with our LambdaTest platform using the username and the access token. And then we are passing these capabilities within the remote WebDriver so that we can connect within our LambdaTest platform. So now everything is all set, and I'm going to run the same test that we executed using Selenium WebDriver, but this time we're going to be running that in the LambdaTest platform. So let me build this solution, and you can see that the test actually changes with the capability name, and now I'm going to run this test. So once the test start executing, if we go to the LambdaTest platform to the automation, you can actually see that there will be a new test coming in, which is the parallel test, which we are currently executing within our machine. And if I click this parallel test, it also shows like what is the capability that we have chosen to run the test for. It's a Windows 10 machine and on the Chrome browser. And you can see it is super fast that our test has already executed. And if I run the play button, you could actually see that the test has currently executed, and it has also recorded test execution for us. So this way, it is very, very easy for us to run the test on the LambdaTest platform in a much simpler fashion. In our next video, we'll discuss how we can run the same test on multiple different browsers in multiple different versions and in multiple different platforms using Selenium's parallel test execution with NUnit's parallelizable attribute in the LambdaTest platform, and we'll see how easy it is to set up an environment and run the same test in multiple different platforms using LambdaTest platform in much simpler fashion. Hi there. This video is the next installment of NUnit tutorial series of Selenium C#. In our previous video, we ran our first NUnit Selenium script over LambdaTest platform. And in this video, we'll discuss how we can execute same test in parallel on multiple browsers with different browser versions and different operating system combinations, same time using powerful LambdaTest platform features. LambdaTest offers over 2000 plus real desktop devices, mobile viewports, and operating system combinations on its cloud-based Selenium Grid. And as you can see in the LambdaTest platform dashboard, based on your subscription, there will be a subscribed limit of the test execution that you can run in parallel. It can be 5, 10, 20, 50, 100, and based upon the licensing model that you are in. So if the limit says 10, then we can run almost 10 different combinations of browsers, operating systems, and versions in the LambdaTest platform. Well, as that said, this time we are going to create a NUnit Selenium C# combo to run parallel test execution on the LambdaTest platform. So I'm going to create a new class. I'm going to call this as parallel testing. We are going to almost write exactly the same operation, but this time we are going to be running the test on the parallel test execution. So for doing that, I'm just going to copy all the existing code. I'm going to paste it over here. I'm going to add the references, and I'm going to change the constructor to parallel testing, and I'm going to add the references for the NUnit and for the Chrome options. And because we are going to be running the test on different environments, so the test fixture cannot be just one like how we did in our earlier test like this, just for Chrome. But this time we are going to be using almost 4 different combinations, like Safari version number 13 with Mac OS Catalina. We're going to run on the Chrome on Windows 10 and Firefox on Windows 10 and Microsoft Edge browser on Windows 10 operating system. And because we're going to be running on 4 different environments, the hard-coded Chrome option needs to be changed to a dynamic browser options, something like this. As you can see, we have a method called as getBrowserOptions, which is going to return as the browser options as Chrome option or Firefox options or Edge options or Safari options based on the browser name that we are passing in. So I'm going to be doing the exact same thing while I'm going to call this particular method so that I can pass the browser name, and that's going to return me the browser options, which can then be used for the capability. And you can see that the return type of this particular method is a dynamic type, which means this can be of any type and will be resolved during runtime. We're going to call the capability using the dynamic keyword as well. So it is going to be capability is equal to get browser options, and we're going to pass in the browser that we have actually obtained from this particular constructor using this particular test fixture. And now we have this particular browser, and now we have the capability or the dynamic capability. But based on the type of browser that you choose, the additional capability parameter also changes. Because for the Safari and the Edge Chrome browser, you don't really have to pass the additional capability with is global environment as true. You don't really have to do that. And that has to be changed as well. So what does that mean is you need to create an if condition where you need to pass that particular additional capability option. So I'm going to be doing that by replacing the existing code from here to this code. As you can see, if the browser type is not equal to Safari and Microsoft Edge, then it is going to use this additional capability pretty much like how we did in our earlier video. But for the otherwise, you need to use this additional capability. And you can see that we don't really pass the is global environment as true over here. And as that said, the capability is almost ready for us right now. And now all we're going to do is we need to change the exception that we are getting from Chrome options to the capability, and the test is almost ready to run on parallel at the moment. And this is the only change that we need to make and run them in parallel in NUnit with C# and Selenium. And once I build the project this time, you can see we have over 4 tests right now with different combinations of browsers and operating systems. And before running the test, we are also going to ensure that the test actually runs in parallel using NUnit. In order to do that, we actually need to set the parallelizable attribute of NUnit as the parallel scope to either fixture or children or self, which you can do using the assembly option. So you can directly pass this assembly of the parallelizable, and you can set the parallel scope to fixture or children or self based on your choice. But we are going to be choosing the fixture this time. The reason being we have different fixture to be executed, and it is always better idea to choose the parallelizable attribute to run in parallel scope as fixtures. And we have almost everything ready right now. But before we actually execute that, we also need to make sure that we uniquely identify these tests on our LambdaTest platform. So I'm going to change this to parallel browser testing as a capability, and I'm going to pass the same thing over here as well. And once we have everything, we are pretty good to go. And now if I try to run this test, and if I go to the LambdaTest platform in our dashboard, you could see that we will have 4 live sessions because we are actually running 4 different browser combinations with different platforms at the moment. You can actually see them executing in the automations tab, and you can directly go to the parallel browser testing that we are actually executing. And if I select that, it will show you all the different browser combinations which the test is actually executing in parallel. And you can see that currently the test has executed in Windows 10 and Firefox, Mac OS and Safari browsers, Windows 10 and Edge Chrome browser, and Windows 10 and Chrome browser. And you can also see how the test is executing by clicking the video option. So this will show you the exact real-time video coming in for you during the execution, which is really handy and which is really cool for us to see how they are actually executing and performing the test in real time. And that is the power of LambdaTest executing test in parallel in multiple different browser combination using Selenium's parallel execution. Hi there. Welcome to the next installment of our NUnit with LambdaTest platform series. In this video, we'll discuss how we can run an locally hosted application onto LambdaTest platform to leverage the power of cross-browser, cross-platform features using LambdaTest tunneling. The LambdaTest tunnel allows you to connect your local system with LambdaTest servers via SSH-based integration tunnel. Once this tunnel is established, you can test your locally hosted applications onto all the 2000 plus browser environments present on the platform. Until our last video, we discussed how we can run tests via NUnit and Selenium C# for single instance test and running multiple tests via parallel execution of NUnit using NUnit's parallelizable features on our LambdaTest platform. And in this video, we'll use the same approach, but just that the application will be hosted within our local machine instead of the public domain as we were doing before. So in order to work with the LambdaTest tunneling feature, we need to do two changes within our code as well as within our machine that we are trying to run the test. And that's very easy to achieve using the LambdaTest platform itself. So if we go to the LambdaTest platform and if we go to the automation, you will see that there will be a configure tunnel options. So this configure tunnel option will give you the command that we need to execute while running the LambdaTest tunneling. So it basically requires an LambdaTest exe file, which is used for tunneling, and then it gives you the user which is running the test and the key which is required to connect to the LambdaTest platform. And this key is exactly the same key that we were using all these days, using the secret key that communicates with the LambdaTest platform via our code. So I'm just going to copy these command and then I'm going to start running it. And if you have not downloaded the LambdaTest tunneling exe, then you can download it from here, as you can see. And once the binary is downloaded, it is super easy to run the binary from our local machine. All we need to do is just to run the command, which is going to be something like this. As you can see, this is the command ./lt.exe-user, my username, and the key as the key which is securely communicating with our LambdaTest platform. And I'm going to trigger the LambdaTest tunneling, and once I trigger the LambdaTest tunneling, it is going to communicate with the LambdaTest platform, and then it is going to achieve a secure LambdaTest connection using SSH, as you can see over here. And now you can see that the tunnel has been started and it says you can start testing the application now. Well, as that said, we are going to run our local machine deployed application on the LambdaTest platform itself. In order to do that, I'm actually going to start an HTTP server for our application which is available within my local machine. So once I do that, I have this particular application deployed. So this can be an application which is deployed within your local Apache server or Internet Information Server or any server of that sort. So I'm just going to run the application, and as you can see over here, this is the application that we have been testing all these days with the public domain, but this time we are going to be running from our local machine. So I'm just going to use the same URL and I'm going to replace the existing publicly hosted domain to the local machine's URL path. And that's it. That is the only change that I have to make for the URL side. But in order for our test to communicate via the tunneling feature that we have enabled, we need to somehow add an additional capability for our remote WebDriver so that it can start communicating with the LambdaTest platform. In order to do that, I'm actually going to add a capability called as tunneling. And then I'm going to make this as true as we used to do it. And I'm going to do the exact same thing for the other capability, which is for Safari and Microsoft Edge. So I'm going to remove the additional is global parameter as true, and that's it. And now I'm going to build this solution, and we can run this test and we'll see how it actually works. So now that our application is up and running, as you can see over here, so in order to run this test, I'm just going to right click and I'm just going to run the test right now. And if we go to the LambdaTest platform over here, you can see that we have a new data available. So I'm just going to refresh them, and you can see that they're currently executing, and you can see that all these tests are getting passed right now. So basically these are the tests which is actually running the application which is running within my local machine. And as you can see within the HTTP server, these URLs are being hit by the LambdaTest test execution which is currently happening. So it's been called by the test execution which just happened. And if I go to any one of the tests over here, you can see that it shows all the test execution completed. And if I choose Firefox with Windows operating system, and if I make this as expanded, you can see that it is currently connecting to 127.0.01 colon 8080 and running the to-do app. So it is not actually connecting the public hosted application, rather it is actually connecting to the application which is deployed within my local machine. So this is the power of the LambdaTest, which allows you to run the test by invoking the application which is deployed on the local machine and running them on the LambdaTest platform in a much simpler fashion. So this way, we have completed a lot of discussion on how to empower our existing test to run on the LambdaTest platform using parallelizable test and single test instance, and also running a local application deployed within our machine onto LambdaTest platform using LambdaTest tunneling. So this ends the complete series with all the discussion that we really required to discuss about on the NUnit testing framework with Selenium C# combo.
Hi guys, greetings from Bulgaria. Today is time for another video. Let me share my screen. Today I'm going to present to you a few patterns, and of course we're going to talk about one of the most famous patterns in automated testing, the page object design pattern. In my book, Design Patterns about in Automated Testing, I described at least 10 variations of this pattern, and it's quite important. And today I'm going to show you how to integrate it in your NUnit tests. Also, don't forget to subscribe to the LambdaTest channel. Always, each week, there are really great videos. And also, don't forget that in the description below, you will find also many different articles and resources, and also the source code that I'm going to show you. So without further ado, first let's discuss the use case, because this time I'm going to use another example, because I want to show you a little bit more complex stuff. Let's agree I created this demo website for the purposes of the book. So it's a simple shopping cart. You can buy stuff, in this case rockets. So you can buy a rocket. As you can see there, these spinners, this meaning that this is an asynchronous request using Ajax without reloading the whole page. Then you can go to view cart, like standard stuff, right? You can update the quantity in the cart. You can apply a coupon. Usually we check that the coupon was applied, and also that we have a taxes and the total is right. And then we'll continue with the workflow where you need to put all of the information here. Again, there will be different test cases where we're checking the different countries, different taxes, etc. We need to verify the information here. Maybe we need to create an account or login with it and place the order. This is our test case. And I already implemented it without using any patterns so that you can see it. I'm using here NUnit. For the NUnit project, you need only a few dependencies, a few NuGet packages. You need NUnit test adapter so that you'll be able to see the tests here in Test Explorer in Visual Studio. We are installing, we're downloading all of the needed drivers with the WebDriver Manager, of course, Selenium WebDriver. This Microsoft.NET Test SDK comes with all of the empty unit testing projects in Visual Studio. And we need .NET Selenium extras. Again, if you don't know how to set it up, there are a few LambdaTest videos on the channel that will help you to figure this out. Next, I created this test class where in the constructor, or also you can do it in test initialize method, we're downloading the driver to the driver manager. We're initializing a Chrome and a WebDriver wait. And this is our test here. I created a few private methods just to group in case you want to multiply the test case a few times with different data. For now, I just move them to private methods inside the class. How we increase the quantity. The most important stuff are that in order to handle some asynchronous issues, we are using the WebDriver wait in this expected conditions element to exist, to wait for particular element to exist on the page or not. And I'm doing it, and basically I'm using this method instead of every time to call driver.findElement, right? It's working quite efficiently. And then I have, in order to remove all the hard-coded pauses, I have two other private methods, wait for Ajax, where basically using the same logic for the WebDriver wait, I'm executing my custom logic where we're executing in this while loop this particular JavaScript where we're waiting for all of the Ajax requests to finish. In this case, we're using jQuery. And the same thing for the wait until page loads completely. We're checking the status of the document to be complete. And afterwards, as I said, I created these private methods to group the logic of the test and to make it a little bit shorter above. And I've hard-coded all of the locators. As you can see, it's a little bit long and it's not quite reusable, right? If you want to multiply this test case and change the data or locator, you need to copy-paste it. Basic WebDriver stuff. We are finding elements, we are clicking them. Again, we are using these two private methods to handle asynchronous issues. And basically, that's it. Now, in order to use the page object pattern, what does it represent? Basically, for each page of this workflow, the home page, the cart page, you can orient yourself from the URL here. We can have a separate class. This class will contain all of the elements with their locators. It will contain all of the different actions that you can perform. For example, increasing the quality and clicking update. Also, in some cases, you can put assertions verifying this price here. It's up to you whether to put these assertions inside the page object or not. Sometimes I prefer to put it because otherwise, especially if you're going to reuse this method on more than one place. Also, if you have some custom exception messages, it will be good to reuse them, right? And also, we can have one more page object for these billing details where instead of having one action method with, for example, 15 parameters, I'm going to show you how is the best way to do it using the so-called POC objects, or basically this is a class that contains all of the data that you need. So let's begin. This time I'm not going to code live since I want to cover a lot of stuff. So I'm going to show you three different versions of the page object pattern. One of them is using three separate files for each page object. First, as you can see, I created here a folder pages. And then for each page, I have a folder with a separate namespace. For the main page, as you can see, we have three files. We have the main page file where this contains all of the actions that we can do, pick a rocket, add it to the cart, whatever, the assertions, and the element map. The element map is basically the properties and the locators of your elements. Then we have one base class for all of the pages. Just a short notice, I'm not using the built-in page objects. My idea is to show you how to do it yourself. More or less, even the project on GitHub for C# haven't been maintained for a while. So I suggest you to try to use your own page objects. So I created here this abstract class. I call it web page. This will be the base class for all of page objects. And here in the constructor, I'm passing the driver, and we are initializing the WebDriver weight. Also, as you can see, as an abstract, we have a property to the URL only with getter, and we have a goto method that first navigates to the page and then calls wait for page to load. As you can see, this is an empty virtual method. Basically, if you don't override it, it will do nothing. But in case you want to, for some reason, wait for a particular element to appear, for example, this may mean that if this field has been loaded, this means that your page has been loaded. So sometimes we want here, before doing any actions, to wait for a particular element to appear on the page. And by the way, this is called a template design pattern. It's another tiny pattern that we're going to use here, combined with the page objects. And then, as you can see here in the base page, I moved these three important methods: the wait and find element, the wait for Ajax, and wait until page loads completely. And let's review what we have. First, we have the main page. The main page derives from this base web page, and we call its constructor and pass the driver through here. And also we have two properties to the map and to the assertions. This means that, again, the map contains properties to all of the elements that you can interact with, and the assertions contains the assertion methods. We are overriding the URL and provide the base URL for the page. And then here we have only one public action, add rocket to the shopping cart with the particular name. And as you can see, we are using the map to get the elements and interact with them. In this case, clicking and so forth, or typing the text. And here, as you can see, I'm using the template method. I'm overriding it. You cannot access it outside of the page because it's protected. And we're waiting for basically this particular part of the screen to appear. And the map, as you can see, it derives from the base map. And all of the elements are marked as get properties. This is the new body expression syntax, but this is similar to, let me show you. This is similar to this. This is just a get property, or in Java, a get method, right? Every time it's waiting for the element to appear, and then we return it. This is quite efficient. Don't think that we need to cache it somehow or whatever. It's fast enough. And the base map is nothing more than, again, just a constructor exposing the wait and find element. As you can see, there is a little bit duplication between this base map and the web page. In the second variation, I will show you how we can fix this. And we do the same for the cart page and the checkout. The cart page, again, contains only the actions. As you can see here, there is a little bit repetition. We can, and through the book, I'm showing how basically we can reuse this using generic base classes. However, I suggest you to keep it simple upfront and later make it a little bit more complex. But again, in version 2, actually, we will work around this with a more elegant approach. And here again, we have the apply coupon action, increasing quantity method, proceed to checkout, get total, and so forth. And again, we are using the template method. The map again contains only the different locators. The good part about the element maps is that if for some reason there is a change in the locators, you need to go only here and fix it, right? Only in a single place, and this will fix your problem. The same for the assertions. Here, we can add custom exception. As you can see, we have arguments, and we can have, as you can see, a message. This message will be displayed a much better exception than just 1 is not equal to 1, right? But again, if you are going just to check it once, maybe it's fine to put it into the test. This is why there are different opinions in the industry about it. I prefer to have this assertion class. But if it's empty, for example, if you don't have assertions, you're not allowed. Basically, you can delete this and don't expose the property. It's up to you. And one more thing, as I said, the checkout page is interesting. Again, the map only contains the different elements on the page. There is one interesting thing that not all of the elements sometimes are not properties, and this is only the case when you need to build dynamically some of the locators, like this here. We are picking the drop-down option based on the country name, and in this case, we are using a method, and this is completely fine to be in the map because it's returning an element. We are building dynamically the XPath or the CSS, and we return the element. And by the way, in these cases, you can use, again, help of the Visual Studio to refactor it, and you can use, again, the expression body syntax. However, I prefer, for readability purposes, my methods to be, even when it's a single line, to keep them like this here, with the brackets, right, on multiple lines. And then only the properties to be on a single line. And the next thing, as I said, instead of passing here, like having 10 arguments, you will see that I created, as I said, a data object holding all of the information that I need to fill into these fields. I named it purchase info. This purchase info basically represents the information that I put into the billing. First name, last name, company, address, whatever, all of that, and also some meta information, whether I should create an account or should check the payment. And as you can see here, we have only one argument, the purchase info. Again, the map and the assertions are initialized in the constructor, and we're exposing them publicly. It's up to you whether to expose the map or not. Sometimes there are people that prefer all of the elements to be private. In this case, you can have the map as a private variable here. And afterwards, as you can see from the map, we're getting the different properties for the elements, and we're just typing the text, and based on the meta information, we're checking whether we want an account or not. And again, because of we're deriving from the web page, we have access to wait for Ajax, wait for page to load completely. And let's see how our test is looking now. Our web pages are here. We are using them through composition. Composition is, again, a pattern that we are not deriving something from a base class. Instead, we're having them here as private variables, and we initialize them inside the class initialize, test initialize, in the constructor, whatever. We are just passing the driver, right? And then the only thing, as you can see, we created, I use sometimes the term DSL or domain-specific language. which makes the tests much more readable and maintainable, meaning that you understand on which particular page you are at this particular line and what action you are doing. And it's becoming something like sentences, right? You're applying a coupon, you're doing an assertion, you're increasing the quantity. It's much more readable compared to the weird syntax where you see all of the details, right? And then, as I said, the only thing that you need for filling the billing information is to supply this purchase info object. And if you want a different test case, you need just to change the data here. It's completely abstract, which is great. Now let's focus on the second version. The second version workarounds the problem with the base map and all of these repetitions of properties. We implement this using partial classes. Partial classes are a feature of C# where you can have 3 different files with different names, but actually they have the same class name, but they are marked as partial, meaning that when you build a project, these 3 files will be combined in the same class, which is really great because now we don't need a base map because everything is a single page. Here we have similar web page. I haven't changed anything, but here, as you can see, our pages are much shorter. Don't have these properties to the map and the assertions. The only thing that we need is to mark them as partial, and that's it. This is the only change. If you look into the test, they look similar, right? We are initializing here the pages. The test is absolutely the same. Also, keep in mind, since in the constructor we're supplying the driver, if you want to execute your test in the cloud, in the LambdaTest cloud, this is the place where you want to initialize all the capabilities of the cloud, etc. Right? Just you need to replace this code here with the code for Lambda setup. Here we are getting from environmental variables the user key and the access key, and instead of ROM driver, we're using the remote WebDriver, passing the formatted URI. And also here you can configure what is the platform, the browser version, browser, etc. All that. And one quick look into a third option for page objects. Here I implemented them as static pages instead of initializing them every time. In order to be able to support that, I created additional class. It's called driver facade. Here we're implementing another pattern. It's called a factory method. Basically, you can think of it as here we're initializing the drivers based on an option. This browser type is basically a enumeration with the different browsers. And into a driver facade, we're initializing the driver and also the WebDriver weight, and we're maximizing the browser. Also, again, if you're using LambdaTest, you need to configure here all the different arguments. And we're exposing static properties, the driver and the WebDriver weight. And I marked basically I moved all of the methods that we had previously in the base web page here, and I marked them as static. That's it. I had to change a little bit the goto method. Right now, we need to pass here the URL and to pass the weight for page load as an action. This is functional programming. This is basically a delegate to anonymous method for waiting for the page. In a minute, we'll see how I implemented it. Basically, the main page is just this. It's marked, again, as static and partial. All of the methods are partial. And here I created additional goto method where I'm calling the driver facade, goto, the URL that I had before. And I moved all of the logic for waiting for the elements here. As you can see, since we don't have any more base class, I need to call the static driver facade, wait, and find element. And we are waiting for this particular div there, right? Of the map, again, all the elements here are static. This is again the same class, but in a different file. And again, we don't have a base class. This is why I'm calling the driver facade where you can find elements. The same for the assertions. Directly, these are static, so I can call them because this is the same class. And I did the same for all of the pages. All of the methods are static. I'm using everywhere the driver facade directly as static. And here is the change. No more private variables. I only started initialize the driver from this static start method, mentioning that it's from. Again, if you're going to run them in the cloud, you need to put the logic here, depending on the environment. And afterwards, I don't need to pass initialize the different pages because they're using the static facade, right? They have a static access to the driver. Keep in mind that if you are going to run the test in parallel, you'll need additional code for synchronizing between different threads, but this is another much more complex topic. And I believe this is even more readable. Sometimes I prefer to use this approach. It's up to you. This is why I showed you 3 variations of it. I hope that it was useful. Thank you for watching. If you have any questions, you can check LambdaTest blog and the support. You can check the community. Also, there are a few really good articles on the LambdaTest blog about this. Also, don't forget to get a certification about Selenium visiting this URL here. And thank you for watching and see you soon.